Okay, so section 6.4 of the textbook contains the do loop. It's one of the sections that contains one of the loops that can be executed. It's mostly used if you want to do one performance of a loop, and yeah, it's best to use the do loop because it just does what you want it to do just once. So right here I have an example of the do loop. It's usually before if you want to do like a while loop or something. So you put it right here. It does this little bit of information, and then it performs the while loop right there.
So what is the difference between a while loop and a do while loop?
Oh, and a do while loop? Well, let me think about this real quick. So the do loop is, well, one of them is separate, one of them's not. The do loop you would do just separate from the while loop, but if you want to do like a do while loop, it doesn't actually like while the while loop is executing anything. Mm-hmm. Is that how it does it? Well, the do loop, it does something separate and then it performs the while loop afterwards, or any conditional statement.
You're talking about the actual test for being inside the loop? Is that what you're talking about?
Yeah.
So how does it differ between that and a while loop?
Well, not too much, but there is a difference because there would obviously be one if you have two ways to do it. But I'm not entirely confident in my answer of why.
Maybe someone in the audience can help.
I think I know.
Yeah.
Gustav?
The do while loop runs the code that's here, and then checks for the Boolean value of the while loop, while the regular while loop checks for the Boolean first, and then if the condition is met, if it's true, they go on and do this.
Right. That's perfect. Basically, the Boolean condition is for determining whether or not to run the loop is actually met in a while loop before you go into the body of the loop. In a do while loop, the Boolean condition or the test is actually run after you've gone inside the body of the loop at least once. So with a do while loop, you run the risk of running the loop once too many times.
Yeah.
So supposing, Mark, you don't want to, supposing the value, the numerical quantity of value is less than 100, it'll still print out, enter an integer less than 100. It'll still print that out one time before it actually gets out of the loop. Contrast that with a while loop. It'll never go inside that loop because the test for determining the quantity that is stored in value is done before it goes inside the body of the loop.
Yeah. That's why some people call it the loop. Like I said here, it's like a post-test loop.
Right.
Because it does it afterwards, while the while or for loops you could use either one or like the pre-test loops.
Right.
It's the way it's organized and like the way it's executed out.
Exactly.
Yeah.
Exactly. Okay.
So like I put a flowchart here of example how it like the flow kind of works. Like let's say like you start here, you do the loop body, and you work it all the way back to condition, then it determines if it's true or false. If it's true, it'll go back here and just keep going until it's false, but then it'll run out the exit of the code. That's just like kind of the same way, but a different kind of format to get two different pictures of it.
Right.
So then, process sentinel values is another. It's 6.5 of it. So like whenever you need to read a sequence, you need to have a method of indicating the end of a sequence. Like you can't go to the code and just start working and then just like get to the end. You have to know what's going to happen, how it's going to format, and how it's going to be an organized block of code. So like here inside the loop, reading output, the input is not -1, we process it. In order to compute the average, we need the total sum of all salaries and the number of inputs. So like basically, it'll stay here, it does the if loop, and it'll like go to the sentinel value, which is not detected. It'll go to the while loop only if it's not -1. But if it is -1, I mean if it's not -1, it's sum equals sum. Wait, hold on, I got lost in this. All right. Then sum equals sum plus salary and it counts it out. Okay. Okay. I got lost on my own. explaining of this, but inside the loop, yeah, it starts with if it's not 1, then it processes it. In order to do that, it needs all this information, but it'll stay inside the while loop while it's executing it. There we go. Like some programmers do not like initializing the input variable with a value other than the sentinel. Another approach is using a Boolean variable. Like right here, it says Boolean done equals false. This is what other people like. Most coders, like I said, they don't like initiating it first, but like they'd rather use a Boolean variable to approach it, which I used in some of my programs to exit out of a loop. Like if I were making a program, I usually do this now if I want to like go back and ask more questions. Like if I ask questions, I'll put it like Boolean equals true, and then if they want to exit the code, I'll put Boolean equals false, so then it stops running the while loop and it like ends the code. Whereas they put it like it keeps it true, it'll keep going through the code over and over and over, and it's just endless. Rather, I prefer to use Boolean for like equals false if I want to exit the code, or exit like a simple expression of code of ask questions. So this is more of like how to like organize your code. Like it's more of a section of how to organize your code that can involve like a storyboard like that filmmakers use for like movies and stuff. It's kind of the same thing. Basically, you can't go into a program and just like start with no plan and then just end it by the finish line. You have to like plan out your code. That's what I do. I first think about like what am I gonna ask the user, and what like happens after I ask them stuff, and then what if I need to what if there's an error in the program? How am I gonna fix that? And when does the program quit? Because I can't just keep it running, just asking random useless questions. I'd rather have like a flowchart of what I'm gonna ask and what's gonna happen.
Well, that's one of the foundations for teaching computer science is this idea of algorithmic thinking, where you take something very complicated, break it down into smaller parts, trying, by using this technique of storyboarding or flowcharting, trying to resolve those somewhat less complicated problems, and then putting it all together into your application. That type of thinking is what a lot of industry professionals expect from people that graduate from college, particularly ones pursuing STEM-related careers. And computer science lends itself nicely to training people with this type of analysis. It's called algorithmic analysis. It's used a lot in conjunction with things like there's a procedure that the private sector uses for rapidly programming applications. It's called Scrum, and it's agile. It's they call it an agile software development cycle, and algorithmic thinking plays heavily in that idea of agile software development.
Yeah. Like I remember like back in C++ 2 years ago, I would just start writing code, and I get frustrated because I'd run into like points that wouldn't work, and I have to like go back and erase a lot of the code. Whereas if I make like a storyboard, or even just like plan out what I want the program to do on a piece of paper, it's more organized. I can easily like do the code with minimal errors.
Right.
So like here's an example. Like if someone wanted to like ask questions of how to make a code, they'll ask like, what unit do you want to convert from? Like say it's a program that like asks the user like certain kind of values, like what do you want to convert to unit 2, and what do you want to convert it from, and then like it'll do like little formulas that you put in, and it'll execute the code. Well, maybe some people like it takes time for them. They need to like organize their thoughts on like a piece of paper. So they'll start asking themselves, what do you want to convert it from? Like what unit do you want to convert it to? Enter the values, they'll write down the formulas, and then they'll like take all that information and then put it into code, organized way, instead of just jumping into the code head on.
Okay, Stephanie, you're up. Thank you.
So the next section is just examples of coding. To find sums and averages, you just compute the sum and keep a running total, so which is a variable to where you add the next input value. So for this code right here, it's asking for the input, which your input, and then it's assigning that you put input and you put another one, and then the new total would be
The old total?
Yeah, the old total plus the new input right here. So, and then to compute an average, you'd keep the total and then divide it by the total number of values that you've counted. So for here, it's counting the total, what you have, which is the same code right here. And then this part right here is counting like the total number of values. So, and then the next section is saying if the count is greater, the average is 0, but like, so the average is 0, and then when the count goes up, you would calculate the average, which is a total divided by the number of values you input in.
So based on your code there, Stephanie, what would you say is a big difference between a while loop and, say, like a for loop? Remember the format or the syntax of a for loop? You have for, and then you have your looping or your counter variable. You initialize it, semicolon. You do some limit, you know, like the counter variable less than 10 or something like that, and then how you increment or decrement the counter variable, right? Whereas here, the while loop is you have a Boolean condition that is met, and if so, then it goes directly into the body of the loop.
Yeah.
What would you say is a major difference between the two?
Well, the for loop, it has an ending, so these codes, they don't have total number.
Yeah, exactly, right, very good. Well, for loop is run a finite number of times, okay, whereas a while loop or a do while, it could presumably run indefinitely, even though in all cases you could conceivably keep track of an amount that is accumulated. Like you can accumulate amounts, but a for loop, you know before you even start running the loop how many times the loop's going to run. Whereas in a while loop, a certain condition has to be met before you know how many times it's going to run.
So this one is about counting matches. To count values that fulfill a condition, you check all of the values and increment a counter for each match. So this code right here, it's showing that for each character is assigned this str.character@. It's assigning like every single character a number. So and turning it into a string. So if the character is a space, then the spaces, like the counter for number of spaces would go up, which is what is shown right here. So in this example, if the string is My Fair Lady, the space is incremented twice when I is at 2 and 7, because after the second value there's a space, and after the 7th value there's another space. To find a match, you exit the loop when the match is found. Here the code is showing that if the value is true and the position is less than the length of the string. So here it's showing, it turns into the string the position of the characters. If the character is a space, then it's a true value, so otherwise you would add another space. To find a value less than 100 or any other value, which is changeable, you can prompt for a number until a match is found. Here, this is asking for an input less than 100, and then it accepts the input right here. If the input is greater than 0, but less than 100, the value is true. Otherwise, it would say an invalid input because it's not between 0 and 100.
And what happens if a match is found?
Then it would just exit.
It would just change the, okay,
It's because it's true.
right.
To find the largest value, you would update the largest value seen so far whenever you see a larger one. So this right here is asking for the next number. After this, like after the first value, if the input is greater than the one before, it would assign a new value to the largest number. When you compare adjacent values, you would store the number input before into a variable. So for here, it's saying the previous is an input. So when you attain another input right here, it's changing it's assigning a new value to the latest input. And if the input is the same as the one before, then it would print the duplicate input.
That's to try to safeguard against people that are entering information and might be entering the same information twice in a row. Okay.
So nested loops occur when you have the body of the loop, when the body of the loop has another loop inside of it. When you're processing tables, nested loops occur naturally. The outer loop iterates over all rows of the table, while the inner loop deals with only what's on the line.
That's really important when we're trying to work with arrays and we're trying to work with two-dimensional data. You want to, if a question comes up on the exam, try to find all the even numbers in this table or in this grid. And the grid is two-dimensional rows and columns. You want to set up a nested loop where the outer loop goes through every row and the inner loop goes through every column. Okay, row by column. Okay, you want to.
And here are examples of nested loops. This first code is showing that for every value I up to 3 incremented. So you would enter a value and then it's repeating the code, so every time you enter a value it would print an asterisk until it reaches 4. So you would have up to 3 lines of 4 asterisks.
3 rows and 4 columns, is that what you're saying?
Yeah.
Okay.
For the next code, for every value of I, when I is less than or equal to 4, you increment it. So as long as j is increasing up to 3, which is shown by the j is less than or equal to 3, you'd print an asterisk, so it would be 4 rows of 3 asterisks.
The third one is kind of interesting, right?
Yes.
The third one, as each row increases, so does the number of columns. As opposed to being a rectangle, this is a triangular way, right?
Yeah. Because here it's saying that the value of I, so as long as the value of I is increasing, j also increases. So for every row there's an extra asterisk.
Right. Okay, let me stop you right there, Stephanie.